Hey everybody, welcome to Chapter 3, Section 2. This is the first video on this section. Here I'm going to go over characteristics of quadratic functions when they're in standard form and vertex form. So at the top of my notes here, I wrote what the standard form and vertex form are. Standard form, you have ax squared plus bx plus c. So a and b are your coefficients. So a is the coefficient in front of x squared, b is the coefficient in front of x. These two terms will never ever combine because this has a power of 2 and this doesn't. So they're not like terms. And then c kind of stands for your constant. It doesn't have any letters by it, so it's just adding or subtracting a number to it. Vertex form doesn't use a, b, and c. It does use a, but I guess I should say it doesn't use b and c. Vertex form uses h and k, and so you'll see formulas with the letters h and k, and generally speaking they mean the vertex. So vertex is denoted as h comma k, and so since the formula has a subtraction sign for the default, so to speak, you're gonna flip the sign. So if it says like x minus, let's say this is a 2, x minus 2, my vertex will be 2 comma whatever k is. You don't flip anything for the k. So if this was like x plus 4, my vertex would be at -4 comma whatever k is. All right. So I put this little note here. Negative h is positive and plus h is negative when you're stating it as the vertex. All right. Some other important information we're going to go over is the axis of symmetry. I'll just refer to it as the AOS from here on out. That's the vertical line that cuts a parabola in half. It goes right through the middle, so it'll run right through the vertex, and it runs through the x-coordinate. See, 4 comma -10, that's the coordinate of the vertex, and then x equals 4 is the equation for the axis of symmetry. And so I wrote that right there. So yeah, if the equation's in vertex form, identifying the axis of symmetry is real easy. It's just x equals h, whatever h is. So here I put an example with actual numbers here. This one's going to be in standard form, this example. And so here I have 0.5x squared minus 4x minus 2. So the number by the x squared is a, 0.5. The number by the x is b, -4. And then I have minus 2 at the end, that's c. I did skip over it. When you have an equation in standard form, you have to use this axis of symmetry formula to figure that out. So it's -b over 2a. So b is already negative, right? So here I have negative. All right, so 2 negatives basically turn into a positive, so that's how I got a positive 4 on top. And then I'm multiplying 2 times a, so 2 times 0.5 is 1. So 4 over 1 is 4. So the axis of symmetry is x equals 4, and then you can clearly see that in this picture. And so the minimum or maximum value, that's the y-coordinate of the vertex. And if you want to calculate that by hand, like let's say you didn't have this graph, all I gave you was this equation, I said what's the vertex? You would do this first, the axis of symmetry formula. Then you would have gotten the x-coordinate of the vertex, and so you plug that into your equation. So I'm going to plug in 4 for x, and then I get -10 when I plug in 4. So that means the y-coordinate of the vertex is -10, so the vertex is at 4, -10. So that's me using these formulas to justify or figure out everything that was identified in this picture. So I'm not going to give you a picture for these two examples. I'm just going to give you the two functions. So we are going to calculate the axis of symmetry, and then we're going to calculate the max or minimum value. I say max or minimum because this is a minimum point because the graph is opening upwards. So if the graph were opening downwards, then we'd have a maximum point because the vertex would be at the top and then the graph is just going down from that point forward. So let's do number 1. Let's label our a, b, and c. So a is, there's no number in front of x squared, so it's understood that there's a 1 in front. So a is 1. B is 2, that's by the x. And then c is by itself, that's negative 1. So I have my a, b, and c. My formula for the axis of symmetry is x equals negative b over 2a. So I'm going to say x equals negative 2 over 2 times 1. So you can use your calculator, you can type it in just like that, but negative 2 over 2 times 1 is negative 1. So x equals negative 1 is my axis of symmetry. And so since I know that the x-coordinate of the axis, the x-coordinate of the vertex is your axis of symmetry, I just plug that in. So f of x now says f of negative 1 because I'm plugging in negative 1. So what is negative 1 squared plus 2x, except x is now negative 1 minus 1. So, feel free to type all that into the calculator. You'll get f of negative 1 equals negative 2, which is your y value, right? So if we figured out our y value and our x value, we'll go down here to this vertex blank, and I'll write negative 1, comma, negative 2. So I put these blanks down here so we're not just going over the vertex and the max or min value. So the max or min value was y equals negative 2, and the axis of symmetry was x equals negative 1. So what is your domain, what is your range, and is it a max or a min? If a is positive, so if a equals positive, then the graph opens up. If the graph opens up, you have a minimum. And then if a is negative, then that means the graph is going to open down. And so if the graph opens down, you have a maximum. Okay? So that's, kind of like the definition if you want to think about it. But if you're really stuck, just look at the graph. So I'm going to go ahead and graph this and show you what I'm talking about. Okay, so here's the graph. You see it opening up. And so if it's opening up, you clearly have a minimum because this is the lowest point. So is it a max or a min? I'm just going to write up slash min because if it's opening up, you have a minimum. So I'm just trying to get that in your head. So that's why I wrote down up slash min. I hope that makes sense. The next thing to go over is just the domain and range. The domain is always all real numbers. Always. Just like absolute value, with the graph is opening up, it's moving left and right, whether it's opening up or down, whether it's opening up or down, skinny or fat, you can plug in any number. Because remember, your function is x squared, or has an x squared, so you're squaring any x value you want. So there's no restrictions with what you can square. So if the graph is on the left and it's on the right, you have all real numbers. And so just remember that it's always all real numbers. So you can say that with the R symbol, or you can do negative infinity to positive infinity. But just make a note that the domain is always all real numbers. All right? Now, the range, that varies. So what was your minimum? Your minimum was negative 2. So the graph is going upwards from negative 2. So just say that y is greater than or equal to negative 2, or you can say it as negative 2 in a bracket and then upwards to infinity, which is not in a bracket, it's in parentheses. So that's everything I can possibly say about number 1. So let's move on to number 2. Number 2, I have negative 2x squared minus 8x plus 1. So I have an a value of negative 2. You're never going to write the x's for your A, B, and C. Your B is -8, and your C is 1. So the axis of symmetry is x equals -b over 2a. So I'm going to have -b, which is negative of -8, over 2 times -2. And so how many negative symbols do we have here? We have 3 negative symbols, so my answer is going to be negative. If you have an even number of negatives, they'll all cancel out. But an odd number, you'll still end up with a negative. So I have, and if you want, I'll say like this. This is going to equal 8 over -4. And 8 divided by -4 is -2. All right, so my axis of symmetry is officially at x equals -2. So I'll write that down in this blank. X equals -2. All right, so now we just need to figure out our max or min thing. So is it a max or a minimum? If a equals -2, that's negative. And so if it's going to be negative, that means it's going to open down. And if it's opening down, then that's going to be a max because the vertex will be the highest point. So I'll say, is it a max or min? It's down, so it's a max. All right, so let's figure out specifically what that max value is. All we have to do is plug in our x equals -2 into our function. So plugging in -2 for x will look like -2 times -2 squared minus 8 times -2 plus 1. So feel free to type in this whole statement minus the f of -2 equals. Type that into your calculator. You should get +9 for your answer. Since +9 is my answer, that's going to be my max value. So I'll just say y equals 9 for my max value. So now I figured out my vertex is at -2, +9. So the goal is ultimately to be able to identify the domain and range without looking at the graph. So I'm going to do that right now. I know the domain is always all real numbers, so you can write it as the R, or you can do -infinity to +infinity. You only have to write one of them, but because this is notes, I'm just going over both. Make sure the infinities are in parentheses. Now the range, I have a maximum value, and I know the graph's opening down. So that means I'm going to have a y is less than or equal to if it's going down. And then what's your max value? 9. See? So I didn't need the graph of that at all. You could also write it as -infinity in parentheses to +9, the highest value in a bracket. All right? You could, of course, check it in the graph. So I will show you the graph right now. Here's the graph. It's going down. I have my vertex labeled -2, 9. So it's going from 9 to -infinity, and it's all real numbers, because even though it's opening down, I can still move left and right all I want. So yeah, that's everything to say about number 2. So let's talk about some examples now in vertex form. So in vertex form, you have your vertex at h, k, and then just remember that h is naturally negative in the formula, so that means you're going to have to flip the sign. But there's like basically no math to do. So I have -3 times x plus 1, so that means I am, if you want to think of it, I'm minusing a -1. So my h value is your axis of symmetry. So I'm going to flip that sign. If it makes more sense to just say flip the sign, then if I see a +1 here, I'm going to write a -1 there. I don't see any number on the outside, so +0. That's my min-max value, the k. So y equals 0. So over here where I wrote the min or maximum stuff, you could just add a note that it's y equals k in vertex form. So there, I wrote it real tiny right there. Y equals K when in vertex form. That's something I probably should have put on there first. But let's get back to the example. So I have my X and my Y. That means I have my vertex. My vertex is at -1, 0. Now let's talk about, is it a max or minimum? Remember, you still have an A in the formula. So A is negative. So we can just make a little note here that A is -3, which means it's going to open down. And if it opens down, then I have a max value. All right? So is it a max or min? It's a max. And this is all doing it without looking at the graph. Now, let's talk about our domain and range. Even in vertex form, it's still going to be a quadratic formula, quadratic equation, right? So it's still going to make a parabola. It's going to be all real numbers. And then my range, since it's opening down, it's going to be less than or equal to, what's that min-max value? 0. Or you can say it as, let's see here. So you're going down, so that means you're going to have to write -infinity to 0 for the maximum value. Okay? And then I did put a blank down here. What are my transformations? If you have a -3 on the outside, you're reflecting over the x from the negative, and you have a 3 on the outside, so that's a vertical stretch, and then this is going left 1. All right? All right, so that's just relating it back to the last video, 3.1, those definitions. Now, I did make this note. Everything can be checked by plugging the function into the graph calculator. These are your steps you would use if you're using the TI Inspire. So let's just quickly take a look at the graph of number 3. Now, I did make a note about for the x-intercepts. That's something we're going to go over in the next video, but I just put it on there. Not thinking about which video it's going to go on, but that doesn't matter. So if this line's distracting you, don't worry about it. We'll talk about it in the next section of the notes. But yeah, for the vertex, this is how you would calculate the vertex in the graphic calculator. So here I have my vertex at -1, 0. You can see, I'm really zoomed in, but you can see it went left 1. All these looks like they're moving over a half, 0.5, 1, 1.5, -2. Yeah, that makes sense. So it went left 1. It's a little skinnier, and it reflected over the x. So yeah, you can check that stuff in the graphing calculator. So let's talk about number 4. Here I have an A of 2, and so if A equals 2, then that's positive. If it's positive, the graph is going to open up. If it's going to open up, then I have a minimum value because the vertex will be the lowest point. So is it a max or a min? It's a min. Now, where's the vertex at? The vertex is at h comma k, and h is the number on the inside, but the opposite sign, so it says -2, so I'm just going to say 2. And then on the outside, it's just regular k, so 5. So that means my axis of symmetry is x equals 2, and my min-max is y equals 5. All right? So I know my domain is all real numbers, and then my range is, well, the lowest point is 5, and then it's going up. So my range is y is greater than or equal to 5, or 5 in a bracket is the lowest point to infinity as the highest that it'll reach. It'll just keep going and going. So what are my transformations? This 2 is up multiplying on the outside. It's bigger than 1. That's a vertical stretch. It's going to go right 2, because this is -2 on the inside. Minus goes right. And then plus 5 is up 5. So yeah, once again, the 2 will make it vertically stretch. The -2 will make it go right 2. The plus 5 makes it go up 5. And then if you're not sure, check everything in the calculator. Here I have my vertex labeled at 2, 5. It's going up, so I know it's going 5 to infinity. It's all real numbers. You can see that it went right 2 and up 5, and it did get a little bit skinnier. So yeah, there's everything. Sorry I ran a little bit long, but thank you for watching. Goodbye.